Assemble.
Hello dear students, I hope all of you have gone through the contents that we had discussed in the previous video, and today we are going to elaborate one of the topic that we had discussed in the previous class, and that is distance formula. The objectives for the day are, the first thing that we'll do is check whether points are collinear or not using distance formula. So we will be using distance formula to check whether points are collinear or not. Before doing that, we'll check what collinear points actually mean. Secondly, we are going to inspect the type of triangle using distance formula and Pythagoras theorem. So the first topic for the day is collinear points. Now if you can break the word properly here, there are two words, co and linear. So co means together and linear means in a line. So those points which are together in a line, they are called collinear points. The exact definition is 3 or more points are said to be collinear if they all lie on a same straight line. So if the points, they all lie on a straight line, then they are said to be collinear. Now look at this picture. These three people, they are standing at point A, B and C. So can you help them decide whether they are collinear or not? See, they are also thinking. And they have mutually decided they are collinear. They are saying we are collinear, as they all are lying on points which can form a straight line. And one more thing that you have to notice here is the distance between A and B, that is AB, and the distance between B and C, that is BC. If we will add them both, then we will get the distance from A to C, that is AC. So we can say if 3 points A, B and C, all these 3 points are arbitrary. We can take any later. So if these 3 points A, B and C, they are collinear as shown in the figure, then we will have AB plus BC equal to AC. To non-collinear points, exact opposite to what we had in collinear points. So the definition will be, if the points, they don't lie on a same straight line, then they are called non-collinear points. If you can look at the picture given here, these three individuals, they are at points such that if you will try to join them with one single straight line, we will not be able to do that. We cannot join them with the help of a single straight line. So as you can see, they cannot be joined with the help of single straight line. So they are called non-collinear points. Now one more thing that you have to notice here is, if 3 points are not collinear, then they may form a triangle. The word is may. In most of the cases they do form, but there can be some exceptions where they may not form a triangle. So most of the cases they'll form a triangle. So we'll say if 3 points are not collinear, then they may form a triangle. So now we will do some questions applying distance formula to check whether the given points are collinear or not, and also to inspect the type of triangle depending upon the nature of question that we have. So the first question today is, we need to check whether the points 8, 1, 3, -4 and 2, -5 are collinear or not. Since there are 3 points, that means we can find 3 distances from these 3 points. So if the points are collinear, then the sum of any 2 distances should result into the third distance. Then we will say the points are collinear, or else we'll say the points are not collinear. So let's start. So given points, we have named them as A, 8, 1, B, 3, -4 and C, 2, -5. A, B and C, they are arbitrary. We could have used any other letter, for instance PQR, XYZ or whatever we wish to. But the thing is, it should not have been predefined in the question itself. If it's already defined in the question, if it's already given in the question that we have to use ABC, PQR or whatever, then we will stick to it. If the points are not given in the question, then we'll give our own points. For instance, we have given A, B and C in this particular question. The next thing that we will do is we will use distance formula. Since we are going to find 3 distances, let's write the formula once at the very beginning, then we will not be writing it again and again. So the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. So the first distance that we are going to calculate is between A and B. A is 8, 1 and B is 3, minus 4. So B we are taking as the second point and A we are taking as the first point. So let us now calculate the distance of AB. AB equals to second point minus first. 3 minus 8 whole square, the first coordinates, and plus minus 4 minus 1 whole square, the second coordinates. So we will get AB equals to 3 minus 8, 8 being the bigger number, so it has a negative sign, so that negative sign will carry on. 8 minus 3 will get 5, that is minus 5 whole square, plus minus minus plus, but sign will remain minus. 4 plus 1 will give us 5, so again minus 5 whole square. So minus into minus plus, 5 5s are 25, so plus 25, another 25 will get equals to 25 plus 25 root over 50. So we can express root over 50 as 5 5s are 25, 25 2s are 50. So the distance of AB will be 5 root over 2 units. Now let's calculate the other distance, that is between B and C. B is 3, minus 4 and C is 2, minus 5. So BC will be second point minus first, that is C minus B. 2 minus 3 whole square plus minus 5 minus minus 4 whole square, as 4 also has a negative sign and one negative sign is from the formula. So BC will be plus minus minus, 3 being the bigger number, minus sign will carry on, minus 1 whole square, minus 5, minus minus plus. So sign for 4 has changed, plus, minus into minus plus whole square. Next up, minus 1 whole square plus 5 being the bigger number, minus sign will carry on, 5 minus 4 will give us 1 whole square. So 1 1s are 1, 1 1s are 1, minus sign will vanish as it is squaring. So BC equals to root over 2 units. So we have calculated distance of BC as well. Now the third distance will be between A and C. A is 8, 1, C is 2, minus 5. So second point minus first point, AC will be 2 minus 8 whole square plus minus 5 minus 1 whole square. Plus minus minus, 8 being the bigger number, minus sign will carry on. 8 minus 2 will be 6 minus 6 whole square plus minus minus plus, but sign will remain minus. 5 plus 1 will be 6. So minus 6 whole square plus minus 6 whole square. So minus into minus plus, 6 6 are 36 plus minus into minus plus, 6 6 are 36. Adding up, we'll get root over 72. So now 72 can be expressed as 6 6 are 36, 36 2s are 72. So AC we will get as 6 root 2 units. So we have got all three distances. Now see whether sum of any two distances can result into third. Definitely we have, since 5 root 2 plus 1 root 2 results into 6 root 2, that is AB plus BC is giving us equal to AC. So this fulfills the condition for collinear points. So we can conclude, hence the given points are collinear. The question is done. Now let's do another question. So the question is, determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. Again, the points were not there, so we have named them arbitrarily as A, B and C again. We could have used any other symbol later as well. So again, we will be using distance formula. So let us first calculate the distance between A and B. A is 1, 5, B is 2, 3. Remember, B is the second point, A is the first point. So second point minus first point whole square. AB will be under root 2 minus 1 whole square. Focus on the first coordinate first, plus now the second coordinate 3 minus 5 whole square. So we'll get 2 minus 1 is 1 square plus 3 minus 5. 5 being the bigger number, minus sign will carry on. 5 minus 3 will give us 2 minus 2 whole square. So 1 1 is 1, minus into minus plus, 2 2 is 4. So under root 1 plus 4 will give us AB equals to root 5 units. Let's quickly find the other distance. B is 2, 3 and C is minus 2, minus 11. So BC will be minus 2 whole square, second minus first, plus minus 11 minus 3 whole square. Second minus first again for the second coordinate. So we'll get minus minus plus, but sign will remain minus. 2 plus 2 is 4, minus 4 whole square. Similarly, minus 11 minus 3 minus 14 whole square. Minus into minus plus, so 4 4s are 16. Minus into minus plus, so 14 14s are 196. If we'll add up, we'll get root over 212. 212, if we'll prime factorize, then we can get 2 into 2. 2 2s are 4, 4 into 53 as 212. That means BC we can express as 2 under root 53 units. Now, the final thing that we need to calculate is the distance between A and C. That is 1, 5 and C is minus 2, minus 11. So the distance of AC will be C minus A, the coordinates, respective coordinates, minus 2 minus 1 whole square plus minus 11 minus 5 whole square. So minus minus plus, sign will remain minus. 2 plus 1, 3 whole square plus minus minus plus, sign will remain minus. 11 plus 5, 16 whole square. So my 3 3 is 9 and 16 16 is 256. Adding up, we'll get AC as 265 root over 265 units. Definitely, root over 5 plus 2 under root 53 will not be equal to under root 265. That is, AB plus BC will not be equals to AC. So this is not fulfilling the condition for collinear points. So we can conclude, hence the given points are not collinear. 265, if we will try to prime factorize, it will not prime factorize. That's why we are leaving it under square root only. So the condition is not satisfied. AB plus BC is not equals to AC. That's why we will conclude the given points are not collinear. The next question is, check whether 5, minus 2, 6, 4 and 7, minus 2 are vertices of an isosceles triangle or not. So first and foremost, we need to think what an isosceles triangle is. An isosceles triangle is a triangle in which any two sides are equal and the third side should be unequal. So let's start. So given vertices, we are naming them again A, B and C. If it's becoming monotonous, you can use any other letter as well. ABC, instead of ABC, you can use PQR, XYZ. So again, we will be using distance formula because we want to find the length or the distance of the sides. So the drill is again the same. So first, let's calculate the distance between A and B. B is the second point. So B, coordinate of B will subtract coordinate of A under square root whole square. So AB will be equals to 6 minus 5 whole square plus 4 minus, since 2 also has minus, minus 2 whole square. So we'll get 6 minus 5 as 1 square, 4 minus minus plus 2 whole square. 1 square plus 4 plus 2 will give us 6 square. So 1 1s are 1, 6 6 are 36. So we have got AB equals to root 37 units. Similarly, let's find the distance between other 2 points. B 6 4 and C 7, minus 2. So BC will be 7 minus 6 whole square plus minus 2 minus 4 whole square. 7 minus 6 is 1 square. Minus minus plus, but sign will remain minus. 2 plus 4 giving us minus 6 whole square. So 1 1s are 1, minus into minus plus, 6 6 are 36. So BC is root over 37 units. So as you can see, the two sides, they are equal now. So do we need to calculate the third side? Yes, we need to calculate it because we need to check whether the third side is also equal or not. Because if the third side is also equal, then the triangle will not be an isosceles triangle. It will be an equilateral triangle. So it's important for us that the third side should not come equal now for it to be an isosceles triangle. So the third side's coordinates are A and C. A is 5, minus 2. C is 7, minus 2. So AC will be 7 minus 5 whole square plus minus 2 minus minus 2 whole square. 7 minus 5 is 2 square plus minus 2 minus into minus plus 2 whole square. So 2 square, 2 to the 4. 2 minus 2 will be 0. 0 square is 0. So we'll only be left with root over 4. So root over 4, 2 into 2 inside square root. So AC is equals to 2 units. So as you can see, AC is not equals to AB and BC. Since AB and BC, the two sides are equal, but they are not equal with the third side AC. So they are satisfying the condition for isosceles triangle. Hence, the given points are vertices of an isosceles triangle. We are done with this. Next question is, we need to determine the type of triangle formed by the points P 3, 2, Q -2, -3 and R 2, 3. In this particular question, the points are already predefined. That means we have to stick with it. We cannot change that since the points are already given in the question. So we will again use distance formula. So let's first find the distance between the 2 points P and Q. P is 3, 2, Q is -2, -3. So PQ will be, Q being the second coordinate, Q will subtract P, -2 -3 whole square, -3 -2 whole square. Minus minus plus, sign will remain minus, 2 plus 3, 5. Similarly, minus minus plus, 3 plus 2, 5. So in both cases, -5 whole square. Minus into minus plus, 5 5s are 25. That means under root 25 plus 25 is equals to root 50. Now, root 50 can be expressed as 5 5s are 25, 25 2s are 50. So PQ is equal to 5 under root 2 units. Now, let's find distance between Q and R. Q is -2 -3 and R is 2, 3. QR equals to R minus Q, that is 2 minus -2 whole square plus 3 minus -3 whole square. 2 minus minus plus, so that is 2, 2 plus 2 whole square. Similarly, 3 minus minus plus, that is 3 plus 3 whole square. So 2 plus 2 is 4, 3 plus 3 is 6. 4 square will give us 4 4 is 16, 6 square will give us 6 6 are 36. Adding those two, we'll get root over 52. 52 can be expressed as 2 2s are 4, 4 13s are 52. So the distance of QR is 2 under root 13 units. Finally, distance of PR now. PR equals to R minus P, that is 2 minus 3 whole square plus 3 minus 2 whole square. Plus minus minus, 3 being the bigger number, minus 1 whole square. 3 minus 2 whole square, that is 3 minus 2, 1 square. So minus into minus plus, 1 1s are 1, 1 1s are 1. So PR is under root 2 units. As you can see, none of the quantities, they are equal. That means all three sides are different. So they are definitely not isosceles or equilateral. They are in fact scaling triangle. But can there be something more to this triangle? Let's check whether these can actually be vertices of a right triangle or not. So whenever we want to check whether the vertices are of a right triangle or not, then we need to focus on the quantities which we have got before prime factorizing. PQ before prime factorizing was root 50. QR before prime factorizing was root 52 and PR was only root 2. Now see, quantities of PQ and PR, if we'll add 50 plus 2, we can get 52. So this way we can say, we can decide whether they can be of right triangle or not. So definitely they can be vertices of right triangle, but we cannot just decide like this. We have to show it. So we'll write. Now PQ square equals to under root 50 square. So square will cancel the square root. That means 50 square units. QR square will be under root 52 whole square. That is, again, square will cancel square root, 52 square units. And PR square will be under root 2 square. So 2 square units. Since 50 plus 2 can give us 52. Now see, what was 50? 50 was PQ square. What was 2? 2 was PR square. And 52 was QR square. So PQ square plus PR square equals to QR square. This satisfies Pythagoras theorem. So since QR is the longest side, so QR is the hypotenuse. So the angle opposite to QR is P. So that means we can also decide which vertex can be of 90 degree. So we can conclude our answer saying, hence the given points PQ and R are vertices of a scaling. We also found that is the triangle is scaling right triangle, and we also found out that it is right angled at P 3, 2. Now our next question is, we need to prove that the points 7, 10, -2, 5 and 3, -4 are vertices of an isosceles right triangle. So there are two things to check, that is isosceles and right triangle. So we can say this question is combination of the previous two questions that we have done, and This question was there in CBSE 2020. That means board exams this year. So we'll start with given points A, B, C. So we have noted them as A, B, C since the points were not there. And if you wish to change it with PQR or XYZ, you can definitely do that. So we'll use distance formula now. That is under root 2 x2 minus x1 whole square plus y2 minus y1 whole square. So firstly, we'll calculate distance between A and B. A is 7, 10. B is minus 2, 5. So AB will be second point minus first point, minus 2 minus 7 whole square plus 5 minus 10 whole square. Minus minus plus, sign will remain minus. 2 plus 7 will give us 9 minus 9 whole square. Plus minus minus, 10 is the bigger number, minus sign will carry on. 10 minus 5 is 5, so that is minus 5 square. Minus into minus plus, 9 9s are 81, minus into minus plus, 5 5s are 25. So we have got root over 81 plus 25. So AB is root over 106 units. Similarly, now distance between B and C. B is minus 2, 5, C is 3, minus 4. So BC will be 3 minus 2 whole square plus minus 4 minus 5 whole square. So 3 minus plus 2 whole square and minus plus, but sign will remain minus. 4 plus 5, 9 whole square. 3 plus 2 is 5 square plus minus 9 whole square. 5 5s are 25 plus minus into minus plus, 9 9s are 81. So BC is also under root 106 units. So far this is quite close to being a isosceles triangle. The two sides are already equal. Now let's inspect the length of the third side. A is 7, 10 and C is 3, minus 4. AC equals to under root 3 minus 7 square plus minus 4 minus 10 whole square. 7 is the bigger number, so minus sign will carry on. 7 minus 3 is minus 4 square plus minus 4 minus 10, that is minus 14 square. So AC equals to under root 16 plus 196, that is AC equals to under root 212 units. So AC is not equal to AB or BC. So AB equals to BC but not equals to AC. This satisfies it's an isosceles triangle. So the first part is done. Now let's check whether it's a right triangle or not. For that, as we have already discussed, that we need to check the quantity that we have got inside square root before prime factorization. In this question, we have not done any prime factorization, so let's straight away check. AB is 106, BC is 106. 106 plus 106 is 212, and that is exactly equal to AC. So we can say now AB square equals to under root 106 square. Square will cancel, square root, that is 106 square units. BC square equals to under root 106 square. So again, square will cancel square root, so 106 square units. AC square equals to under root 212 whole square, that is square will cancel square root, 212 square units. Now, since we are measuring distance, that's why we are writing units, because distance will have some unit. Since it's a coordinate, that's why the units are not fixed, but it will have some units. That's why we are just writing units. Now here, 106 plus 106 will give us 212. That is, AB square plus BC square is equals to AC square. Now, AC is the largest side, longest side. In fact, AC is the longest side. So that is, it's a hypotenuse. AC is the hypotenuse. So opposite to AC definitely will have B. So the right angle is right angled at B. We have found out that as well, although that was not asked in the question. So we can conclude, hence the given points A, B and C forms an isosceles right triangle. Only this much was asked, but we also found out that it is right angled at minus 2, 5. How we found out that? We found out that AC is the longest side, that is the hypotenuse. So opposite to AC we will have B, so it is right angled at B. The angle that is opposite to hypotenuse is the right angle. Let's do one more question, and the question is, prove that the points 3, 0, 6, 4 and minus 1, 3 are vertices of an isosceles right triangle, and we also need to find its area. So the new addition is we also need to find its area. In the previous question also we did the same thing, but we did not have to calculate the area. Now the given points, let's name them for a change, P, Q and R. So let's use distance formula. Firstly, we'll find distance between P and Q, 3, 0 and 6, 4. So PQ will be 6 minus 3 whole square plus 4 minus 0 whole square. 6 minus 3 is 3 square plus 4 minus 0 is 4 square. 3 3s are 9, 4 4s are 16. So under root 25. It can be written as 5 into 5. So PQ is 5 units. Now let's find distance of QR. QR will be equals to minus 1 minus 6 whole square plus 3 minus 4 whole square. Minus minus plus, but sign will remain minus. 6 plus 1 minus 7 whole square. Plus minus minus, 4 is the bigger number, minus sign will carry on. 4 minus 3 will give us 1, minus 1 whole square. Minus into minus plus, 7 7s are 49, plus minus into minus plus, 1 1s are 1. 49 plus 1, root over 50. It can be expressed as 5 into 5 into 2, that is, QR is 5 under root 2 units. Now, the third distance, P is 3 0 and R is minus 1 3. So minus 1 minus 3 whole square plus 3 minus 0 square. PR is minus minus plus, sign will remain minus, minus 4 whole square plus 3 minus 0 will be 3 square. So PR equals to under root 16 plus 9, that is under root 25. So PR equals to 5 into 5, that is PR is 5 units. So as you can see, two sides are equal and the third side is unequal. That is PQ equals to PR but not equals to QR. So it satisfies the criteria for isosceles triangle. So definitely it's an isosceles triangle. Now in order to check right triangle, we need to look at the quantities which were inside square root before prime factorization. For PQ we had 25, for QR we had 50, and for PR we had 25. 25 plus 25 can give us 50. So we have found out that it can be a right triangle. So let's summarize. Now PQ square equals to root over 25 whole square. So square will cancel under root 25 square units. Similarly, QR square equals to root 50 whole square. So square will cancel under root 50 square units. PR square is equals to under root 25 square. So square will cancel under root 25 square units. Here 25 plus 25 will give us 50. That is PQ square plus PR square equals to QR square. So it satisfies Pythagoras theorem. Now since QR is the longest side, so QR is the hypotenuse, and the angle that will be opposite of QR will be P. So we have also found out that it is right angled at P. So we can conclude, hence the given points PQ and R are vertices of an isosceles right triangle. Only this much was asked, but we also found out it is right angled at P 3, 0. Remember, we also had to calculate the area of the triangle. Now since it's a right triangle, we can use the identity area of triangle equals to half into base into height. Since QR is the hypotenuse, so definitely PQ and PR are the base and height of the right triangle. So area of PQR we can write half into PQ into PR. QR is the hypotenuse, so we are using PQ and PR as base and height. So half into 5 into 5. PQ was also 5, PR was also 5. So 5 5s are 25 by 2 square units. So area of triangle PQR is 25 by 2 square units. Or if you divide, area of PQR is equals to 10.5 square units. And dear students, also remember this thing that we always write units after calculating the distance, because distance is a quantity which can be measured and it will have some unit. It can have unit like meter, centimeter, kilometer or anything. So since we are not aware of it, we are simply writing units. It can be replaced by any of those measuring units later. Now these are assignments for you, so try to do these questions. These are similar to the ones which we have discussed in the video. And don't forget, it all started with a fly and a man named René Descartes. Thank you and have a nice day.